Hi, I am Sanjay Patel. In today's lecture, we are going to continue with the problems based on beta and gamma functions. In the previous video also, we have solved some 5 or 6 problems on this topic. So let us continue with some more examples. So, I'm starting with the first one. So find the value of integral 0 to 1 x raised to 5 into 1 minus x cube whole raised to 10 dx. Okay. Now for solving this, we'll convert this into, say, beta gamma function, whatever is possible. So first of all, let us think about what to take as a substitution to convert this into some known form of beta and gamma functions. If I take, say, x cube is equal to something, then derivative of x cube is 3x square, and that x square I can get from this x raised to 5, and the remaining x cube I can keep that variable or that substitution d. So that gives me some idea that what to take as a substitution. So let us try x cube is equal to t. If x cube is equal to t, we can write 3 into x square dx is equal to dt. Okay, so I can write x square into dx is equal to 1 by 3 times dt. Okay, also when x is equal to 0, t is equal to 0 is obvious from the given relation. This is our main substitution. X cube is equal to t, and when x is equal to 1, we have t is equal to 1. So putting these values in this integral, let me write down again. This gives us 0 to 1 x raised to 5 into 1 minus x cube raised to 10 dx is equal to integral 0 to 1. This I can write as, say, x cube into 1 minus x cube raised to 10 into x square into dx. So I am splitting this x raised to 5 in as x cube into x square. So I can now substitute x cube is equal to t, and the new limits of integration. So this gives me t equal to 0 to 1, x cube is equal to t, 1 minus x cube, that is 1 minus t raised to 10, and x square dx, that is 1 by 3 times dt. It is already obtained here. So this is equal to, it is now in the standard form of say beta function. So if you compare with the formula of beta function, beta mn is equal to integral 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. M minus 1 is, say, 1 here, that is power of t. So I can write this is equal to beta of, if m minus 1 is 1, so m is equal to 2, and n minus 1 is 10, so n is equal to 11. You must think like this: the power of t, which is 1, that you can compare with this m minus 1. So in the case, just if you want to find values of m and n, just add 1 to the power of t and power of 1 minus t. That's all. So this is equal to gamma 2 into gamma 11 by the relation between beta and gamma function upon gamma 13. Okay. And yes, I forgot to write 1 by 3 here. This 1 by 3 is a constant. I can keep it outside of this integral sign. So this is equal to 1 by 3, gamma 2 is 1 factorial and gamma 11 is 10 factorial upon gamma 13 is 12 factorial. So just if you simplify this, what you will be left is 1 upon 3 into 1 upon 11 into 12. And if you multiply these three numbers, 11 into 12 into 3, you will get 396. Okay, correct. So this is the value of the required integral. The next problem. Say, prove that integral a to b x minus a raised to p into b minus x whole raised to q dx is equal to b minus a raised to p plus q plus 1 and into beta of p plus 1 comma q plus 1, and here we are given that a is not equal to b. So let us solve this problem. I start with the left hand side integral and I want to get rid of all this x minus a, b minus x and bring here some standard form. There are many ways you can do this. I will start with a spatial substitution and also show you another simple way of doing it. But this simplifies the things. So let us take a spatial substitution for this problem. X is equal to a into say sine square theta plus b into cos square theta. If we consider this, then immediately I can add dx is equal to say 2a sine theta, derivative of sine square theta is 2 sine theta into cos theta plus derivative of cos square theta is 2 cos theta and derivative of cos theta is minus sine theta. Okay, this into d theta. Okay, so that implies dx is equal to, here you can take say 2 sine theta cos theta as a common factor. It appears in both the terms. So 2 sine theta cos theta, this is minus b and this is plus a, so I will get a minus b into d theta. Okay, a minus b into d theta. Okay, also whenever we take a substitution in the definite integral, we have to change the limits of integration for the new variable. So the new limits for x is equal to say a, we have if I put x is equal to a here, what I will get is a is equal to means a is equal to a sine square theta, so that gives me cos square theta. Let me write like this. So we get a is equal to a sine square theta plus b into cos square theta. So that gives us a into cos square theta is equal to b into cos square theta, correct? Because 1 minus sine square is cos square. So this gives us a minus b into cos square theta is equal to 0. But we are given that a is not equal to b. So a minus b is not 0. And therefore cos square theta must be 0. And if cos square theta is equal to 0, that means theta is equal to pi by 2. Okay? Because a is not equal to b, so a minus b is not 0. Also, when x is equal to b, what you will get is b is equal to a sin square theta plus b cos square theta. In this case, if you simplify, taking this term on the other side, you will get b into sin square theta, because 1 minus cos square is sin square, and here in the right hand side a into sin square theta. So this gives us b minus a into sin square theta equal to 0, correct? Again, as a is not equal to b, we must have sin square theta equal to 0, because a minus b is not 0 as a is not equal to b, or b minus a is not 0. And therefore, sin theta is 0 gives us theta is equal to 0. So what I have proved here is when x equal to a, theta is equal to pi by 2, and when x equal to b, theta is equal to 0. So we have found the corresponding limits of this integral. Still, to simplify this in an easy way, we must calculate or find the expression for x minus a and b minus x using this substitution. So let me write this way. Also, x minus a, you know what is x is a into sin square theta plus b into cos square theta, and this minus a means b into cos square theta minus a into 1 minus sin square theta, taking a common from these two terms, this and this. So I can write the next step as b into cos square theta. This is also cos square theta, so b minus a times cos square theta. So I can replace x minus a by this expression. So therefore, x minus a is equal to this. Okay. Again, I want b minus x, which is in the integrand. This term is can simplify a sin square theta plus b cos square theta. Okay, that gives us b into 1 minus cos square theta, taking b common from these two terms, this and the first term, and minus a sin square theta as it is. Again, 1 minus cos square is sin square, so taking sin square common, we will get b minus a times sin square theta. So what I have proved here is that b minus x is equal to b minus a into sin square theta. So these are all useful results. This is the first one. This is another one. Okay. This is the number 2. And we also want these limits, this and this, theta is equal to pi by 2 and 0. And finally, this dx, which is 2 sin theta cos theta into a minus b. Okay, this we can substitute in the given integral a to b, x minus a raised to p into b minus x raised to q. So let me write down that. So thus, integral a to b x minus a raised to p into b minus x raised to q dx, we can write as, when x equal to a, we have theta is equal to pi by 2. When x equal to b, we have theta is equal to 0. We have obtained x minus a expression, which is here in result 1, that is b minus a into cos square theta. I will write b minus a into cos square theta raised to p, and b minus x, it is here, that is b minus a into sine square theta raised to q, and finally dx, what was dx? I think it is 2 sine theta cos theta into a minus b. Yes, it is 2 sine theta cos theta into a minus b d theta. So let us write the dx, 2 into sine theta into cos theta into a minus b into d theta. Okay. Now I have everywhere here b minus a. So I want to make these also in the form b minus a. So taking minus sign outside of this integral and pi by 2 to 0 and b minus a raised to q, sorry p, then here cos raised to 2p theta, b minus a raised to q, then sine raised to 2q theta, then into 2 sine theta cos theta into b minus a. I have taken minus 1 as a common factor outside of this integral sign, and now I can change this integral limits to make it plus. So this gives me integral 0 to pi by 2, 0 to pi by 2, and one more thing, I can keep all this b minus a power here outside of this integral sign as it is constant. So let me write like this. This is equal to, this is b minus a raised to p, b minus a raised to q, and this is b minus a. So it is b minus a raised to p plus q plus 1, correct? And the remaining thing, that is 2 into, we have cos raised to 2p plus 1 theta, then sine raised to 2q plus 1 theta d theta. That 2 also I can write outside of this integral sign. So this is equal to 2 times b minus a raised to p plus q plus 1 integral 0 to pi by 2. And now you know this is familiar term. So cos raised to 2p plus 1 theta into sine raised to 2q plus 1 theta d theta. Okay. And we have that formula for beta function in terms of this sine and cos. Just using that formula, I can write this as, if I write that 2 here, then this 2 times this thing, this constant I am keeping as it is, p plus q plus 1. This is given by beta of the sine raised to p cos raised to q formula. If you remember, this is power, you can say p, which is 2q plus 1. So what I will get is beta, say 2q plus 1 by 2, comma 2p plus 1 by 2. So I am using that formula, integral 0 to pi by 2 sine raised to p into cos raised to q is equal to 1 by 2 times beta of p plus 1 by 2, comma q plus 1 by 2. So that's all. Just simplifying, this gives us, this is beta of 2q plus 2 upon 2 gives us beta of q plus 1, and this is p plus 1. Okay, and that's all. That is the required. So I can write it as beta p plus 1 comma q plus 1 because beta function is symmetric in its argument. So this is the required result. Okay, so we have proved this thing. In this problem, instead of this substitution, You can also take say x minus a. You can take x minus a is equal to say y and then proceed, or you can take x minus a is equal to b minus a times y. So there are other options I am giving you as another hint. Let me write in a special way. Yes, alternative option, alternate substitution. You can write x minus a is equal to b minus a into y. This is one substitution. Another substitution I can give you is x minus a is equal to simply y, and then later on you can change, or you can take a new substitution for y upon b minus a is equal to z, and that will help you to solve this problem in another way. So let's go to the next problem now. So problem number 3. Let us find the value of the integral 0 to 1 x raised to 6 into 1 minus x square raised to 1 by 2 dx. Okay. So here also let us take some substitution for say something. I think it is easy to take for x square. Yes, let us take x square is equal to t. Remember, this is not the only way. You can take some other substitution also, like one can take x equal to sine theta, so it will convert everything into sine and cos, and you can use the beta function. Let me use this x square is equal to t substitution. Let me write here alternatively. Alternate substitution you can write as x is equal to sine theta. Now x square is equal to t gives us 2x dx is equal to dt. Okay, and therefore what you will get is x into dx is equal to 1 by 2 times dt. And when x is equal to 0, we have t is equal to 0. When x is equal to 1, we have t is equal to 1 from this substitution, this relation. Okay, so putting all these values in our given integral, what I will get here is integral 0 to 1 x raised to 6 into 1 minus x square raised to 1 by 2 dx. Okay, this is equal to integral 0 to 1. I can take x raised to 5, but okay, this is, I can write as say x square raised to 3, 1 minus x square raised to 1 by 2 into dx. Okay, just remember that from this result I can write dx is equal to 1 upon 2x, and that x I can write as root t dt, because x square is equal to t, so x is equal to root t. Putting all these values in this integral, what we'll get is integral 0 to 1, and then x square is t, so t cube into 1 minus t raised to 1 by 2 into 1 upon 2 root t dt. Simplifying, so this will give us 0 to 1. This is t raised to 3 and this is t raised to 1 by 2. So t raised to 3 minus 1 by 2, that is what is it? 3 minus 1 by 2, that is 5 by 2. Okay, and this is 1 minus t raised to 1 by 2 dt. So again it is a beta function. I can write directly from the definition. Just here to add 1 to each of this power. The formula for beta mn, is 0 to 1 t raised to m minus 1. So this number is m minus 1. So m is equal to this number plus 1. So 5 by 2 plus 1. So I can write directly it is 7 by 2. And this is n minus 1. Let me write here so that you can understand. M minus 1 is 5 by 2 and n minus 1 is 1 by 2. So m is equal to 5 by 2 plus 1 and n is equal to 1 plus 1 by 2. So it is 3 by 2. This is equal to, now we can use that relation between beta gamma function and find the value of this beta function. So gamma 7 by 2, gamma 3 by 2 upon gamma 7 by 2 plus 3 by 2. This is equal to 1 by 2. This I can write as 7 by 2 means what? I can write it as 5 by 2 plus 1. Yes. So gamma 5 by 2 plus 1. And this I can write as gamma, say 1 by 2 plus 1. Right? And this denominator is 7 plus 3, that is 10 by 2. So it is gamma 5. Why I am writing like this? Because I want to use the formula of gamma n plus 1, which I can write as n into gamma n. So this is equal to 1 by 2 into 5 by 2 gamma 5 by 2 into 1 by 2 into gamma 1 by 2 upon gamma 5 is 4 factorial. So I am using the formula gamma n plus 1 is equal to n into gamma n. Further, simplifying this term, 1 by 2, again 5 by 2 I can write as 3 by 2 plus 1, or okay, so let me write 5 by 2 into, this is 3 by 2 plus 1, so I am writing directly 3 by 2 gamma 3 by 2 into 1 by 2 into gamma 1 by 2, as it is 4 factorial, here is 24. Okay. So further, if you just simplify everything, this is what? 2, 2, 2, 1, 2, 3, 2 to the 4, 2 to the 8, to the 16, and numerator is 15. So 15 upon 16 into 24 into gamma 3 by 2 into gamma 1 by 2. But still I can simplify gamma 3 by 2 and write it as 1 by 2 gamma 1 by 2. So 15 by 16 into 24 into 1 by 2 gamma 1 by 2 into gamma 1 by 2. This is as it is. Because 3 by 2 you can add as 1 by 2 plus 1, and again using the formula gamma n plus 1 is equal to n gamma n. So this, if you write 15 upon this 32 into 24, 32 into 24, and gamma 1 by 2 square. Okay. So this, if you simplify, you will get this is equal to 15 upon, if you multiply these two numbers, 4 to the 8 and this. So you will get 15 upon 768, right? 768 into gamma 1 by 2 is square root of pi. So this gives us, still there is a factor 3 in common. Yes, so I can cancel this. 5 3 is 15 and dividing this by 3. So 3 2s are 6, 1, 3 5s are 15, and 3 6 are 18 into pi. So our answer is 5 by 256 times pi. Okay. Okay, let us solve the next problem. Problem number 4. Prove that integral 0 to infinity 1 upon 1 plus x raised to 4 dx is equal to pi upon 2 root 2. Okay. Let us solve this. To convert this into some beta or gamma function, we take some substitution. Here it is x raised to 4. So I cannot take sine or cos because it is 1 plus something. So that let us take say x square is equal to tan theta, or you can say x is equal to root tan theta. Let's take x is equal to say root tan theta. So therefore we will get dx is equal to 1 upon 2 root tan theta. Derivative of root of something is 1 upon 2 root of something, and derivative of tan theta is x square theta into d theta. Okay. Fine. And therefore I can write the integral 0 to infinity 1 upon 1 plus x raised to 4 dx, okay, is equal to, I have to change the limits also, so let me write it over here. When x is equal to 0, if you put x equal to 0 here, tan theta is 0, means theta is equal to 0. And when x is equal to infinity, we have tan theta is infinity at theta is equal to pi by 2. So this limits will change to 0 to pi by 2. So integral 0 to pi by 2 and 1 upon 1 plus x raised to 4. X square is tan theta, so it is 1 plus tan square theta, and dx we have already obtained 1 upon 2 root tan theta into sec square theta d theta. Okay, so this is now very simple. This 2 will be cancelled. This 1 plus tan square theta is sec square theta will be cancelled with this, and you will get 1 upon 2 times integral 0 to pi by 2 1 upon root tan theta, that is tan theta, this I can write as the root tan theta is root sin theta upon cos theta. So let me write directly that, just a minute, I can write this as root of cos theta upon sin theta. Tan is sin upon cos, so 1 upon tan is cos upon sin, so that will go in the numerator, and the square root sign is also there. This I can write as 1 by 2 integral 0 to pi by 2 sin raised to minus 1 by 2 theta into cos raised to plus 1 by 2 theta d theta. Okay, so this is nothing but the beta function, which I can write as 1 by 2 into, again the formula, 1 by 2 times beta of minus 1 by 2 plus 1 by 2 and q plus 1 by 2. So 0 to pi by 2 sin raised to p cos raised to q theta d theta is equal to 1 by 2 times beta of p plus 1 by 2, comma q plus 1 by 2. So using that formula, you will get this. This is nothing, beta of 1 by 4, and this is 1 by 2 plus 1 means 3 by 4. This is 3 by 4. So what I will get here is, this is equal to 1 by 4 gamma 1 by 4 gamma 3 by 4 upon gamma of 1 by 4 plus 3 by 4, using the relation between beta and gamma function. So this is equal to 1 by 4. This I can write as 1 by 4, and 3 by 4, 3 by 4 I can write as, say, 1 by 4 plus 1 by 2 is right. Here you will get 2, 2 plus 1 is 3, and this denominator is gamma of 3 plus 1, that is 4 by 4, so it is gamma of 1, and gamma 1 is 1, so we are left with only 1 by 4 times gamma of 1 by 4 into gamma of 1 by 4 plus 1 by 2. Now just try to recall that we are having something like this, gamma n into gamma n plus 1 by 2 in some formula, and that is the most important formula, which is known as duplication formula. So let me write here. You know that gamma 2n is equal to 2 raised to 2n minus 1 upon root pi into gamma n plus 1 by 2. So if I use this formula, then I need only, say, this term here. So this is equal to gamma 2n into root pi by 2 raised to 2n minus 1. Here n is equal to, in this case, here n is equal to 1 by 4 from this. So this is equal to 1 by 4 gamma 2 into 1 by 4, okay, into root pi upon 2 raised to 2 into 1 by 4 minus 1. And simplifying this, we will get our required value of the integral. So 1 by 4, this is gamma 1 by 2 into root pi upon, this is 2 raised to 1 by 2 minus 1. Yes, so it is minus 1 by 2. So finally you will get this root 2 upon 4, and this is root pi into root pi, correct? So our answer is, this is equal to root pi into root pi is pi, and this 4 I can write as 2 to the 4, and that 1 2 will be cancelled with this above root 2, and we get 2 root 2. So answer is pi upon 2 root 2. Okay, so this is the required value. Let us go to the next problem. I think this is problem number 5. Prove that integral 0 to 2 x raised to 4 into 8 minus x cube raised to minus 1 by 3 x raised to minus 1 by 3 dx. This is equal to 16 by 3 into beta of 5 by 2 comma 2 by 3. Okay, so let us solve this problem. It's also an interesting one. For solving this, I want to get rid of this 8 minus x cube raised to minus 1 by 3 and to convert this into simpler form. So if I replace this 8 minus x cube, okay, or say x cube by something, say if I write x cube is equal to say 8 times sine square theta, then this gives me 8 minus 8 sine square theta, so 8 into cos square theta, yes. So that will simplify this thing, and this implies I will get x is equal to 2 into sine raised to 2 by 3 d theta. So therefore dx is equal to 2 into 2 by 3 sine raised to 2 by 3 minus 1. Okay, so it is 2 by 3 minus 1. So 3 minus 1, I mean minus 3 plus 2 is minus 1 by 3. So what I will get is sine raised to minus 1 by 3 theta, and derivative of sine theta is cos theta d theta. So we are applying the chain rule for differentiating both the sides. So dx is equal to 2. Derivative of sine raised to something is something into sine raised to something minus 1. So it is minus 1 by 3 into derivative of sine theta is cos theta. Fine. So that is 4 by 3 times sine raised to minus 1 by 3 theta into cos theta into d theta. Okay. Further, if you now substitute all the values, but before that I should also take care of the limits of integration. So when x is equal to 0, I can put x equal to 0 here or here in this substitution. X equal to 0, we get 8 sine square theta is equal to 0. That is sine theta is equal to 0. Sine theta is equal to 0, that is theta is equal to 0. And when x is equal to 2, see upper limit of integration is 2. When x equal to 2, I can use this result and write sine raised to 2 by 3 is equal to 1. So sine theta is 1 and therefore theta is pi by 2. Now I can change the integral and write it as integral 0 to 2, that was given to us, x raised to 4 into 8 minus x cube raised to minus 1 by 3 dx. We can write it as integral 0 to pi by 2 x raised to 4. The x is 2 sine raised to 2 by 3 theta. So this raised to 4, 8 minus x cube. So it is 8 minus 8 into sine square theta, because we have taken x cube is equal to sine square theta raised to minus 1 by 3 into this thing dx, that is into 4 by 3 into sine raised to minus 1 by 3 theta cos theta d theta. This will write as this is equal to integral 0 to pi by 2, 2 raised to 4 is 16, then sine raised to 8 by 3 theta, and this is 8 minus 8 sine square theta, so it is 8 into cos square theta raised to minus 1 by 3 into 4 by 3 into sine raised to minus 1 by 3 theta into cos theta into d theta. And from this I can add 16 for the 64 by 3 integral 0 to pi by 2. This is sine raised to 8 by 3 and sine raised to minus 1 by 3. That gives me sine raised to say 7 by 3. Okay, sine raised to 7 by 3 theta. 8 raised to minus 1 by 3 is 1 upon 2. It is 1 upon 8 raised to 1 by 3, so it is 1 upon 2. And cos raised to minus 2 by 3, and let me write like this, one more step, into cos theta d theta. So this gives me 16 by, sorry, this 2 will cancel this, so we'll get 32 here. So 32 by 3 integral 0 to pi by 2 sine raised to 7 by 3 theta into cos raised to minus 2 by 3 plus 1. So it is 3 plus 3 minus 2, that is 1 by 3 theta d theta. So it is now in terms of the beta function, which is known to us, 0 to pi by 2 sine raised to p cos raised to q. So that gives us 1 by 2 times beta 7 by 3 plus 1 by 2 and 1 by 3 plus 1 by 2. So this is equal to 32 by 6, rather I can write 16 by 3 into beta of 7 plus 3 is 10 by 3 and by 2, so that is 5 by 3, correct? Yes, this 2 will cancel that, and 1 plus 1 by 3 is 4 by 3 and 4 by 3 by 2 is 2 by 3. Fine. So this now we can write in terms of gamma function using the relation between beta gamma. So this into gamma 5 by 3, or I think it is not required actually, because our answer is only this much. Let me check here. 16 by 3 into beta of 5 by 2 comma 2 by 3, and that's all. Yes, 16 by 3 into 5 by, this is 3 actually, it is not 2, 5 by 3. So we have obtained our answer. So the result is proved. This is equal to RHS. So 16 by 3 into beta of 5 by 3 comma 2 by 3. This is RHS. Fine. And let us go to the last problem. Say, I think it is problem number 5 or 6. Let me check. Yes. This is problem number 6. Prove that x raised to a into integral 0 to 1 t raised to x minus 1 into log of 1 upon t raised to x minus 1, or rather a minus 1 dt is equal to gamma a. Here a is positive, x is also positive, and t is also positive. Okay, let us solve. I start with the right hand side, that is x raised to a integral 0 to 1 t raised to x minus 1 log of 1 upon t raised to a minus 1 dt. Here, remember that a and x are constant in this problem. A and x both are constants. Okay. And to solve this, let me take a substitution for say log of 1 upon t. Let log of 1 upon t is equal to say u. Okay. And that implies we will get 1 upon t is equal to e raised to u, and hence t is equal to e raised to minus u. T is equal to e raised to minus u. Therefore dt is equal to minus e raised to minus u into du. Okay. Derivative of e raised to x is e raised to x, and that derivative of this x is minus 1. So that is one part. Also, when x equal to 0, or rather t equal to 0, remember the variable is t here. When t equal to 0, we have log of 1 upon 0, that is log infinity. So u is equal to infinity, and when t is equal to 1, we will get log 1 upon 1. So log 1 is 0, and therefore u is equal to 0. Putting all these values in that integral, so we'll get integral other x raised to a integral 0 to 1 t raised to x minus 1 into log of 1 upon t raised to a minus 1 dt is equal to x raised to a into integral infinity to 0, okay, infinity to 0 into t. T is e raised to minus u, so we'll get e raised to minus u raised to x minus 1 log of 1 upon t. We have taken log of 1 upon t as u, so this is u raised to a minus 1, and dt is minus e raised to minus u into du, right? And interchanging these limits will make this sign plus. So let me change the limits of integration, interchange the limits of integration. So 0 to infinity, this is u raised to minus ux plus x, sorry, it is e raised to minus ux and plus u into u raised to a minus 1 into e raised to minus u du. So which I can add as x raised to a into e raised to, let me write this term first, u raised to a minus 1 into e raised to minus ux only into du. The variable is u here, remember, not x. And this is similar to gamma function, but that u should not be there in this, rather this constant x is not there. So what should I do is, let me change this by taking a substitution. So take v is equal to ux, and therefore I can write dv is equal to x into du. Remember, x is constant, and also when x, rather u equal to 0, we have v is equal to 0. When u is equal to infinity, we have v is equal to infinity. So that integral, the above integral, I can write as x raised to a integral 0 to infinity. U is v upon x, so it is v upon x raised to a minus 1 into e raised to ux, that is minus v, and du is 1 upon x into dv. Simplifying this, what we'll get here is this is equal to x raised to a integral 0 to infinity v raised to a minus 1 into e raised to minus v into 1 upon x raised to a minus 1 plus 1 dv. And this will be cancelled. X raised to a and this x raised to a will be cancelled. And what I will get is integral 0 to infinity integral 0 to infinity v raised to a minus 1 into e raised to minus v dv. Just replacing v by x just for your simplicity, not as a substitution. So I can add x raised to a minus 1 into e raised to minus x dx. Just replace v by x. So what you will get is, this is nothing but gamma of a, correct? And hence it is proved. This is equal to your RHS. So we have proved this result. Okay. And this is all about different types of problems based on beta and gamma function. And this completes our topic of beta gamma functions. So thank you and goodbye.